So welcome to the Roden Schwartz booth and our demo of Wi-Fi 7 signaling on the CMX500 radio communication tester. The CMX500, I guess everybody knows that, is our Radiocom tester, our one-box tester that covers LTE, 5G FR1, 5G FR2, red cap, and all these kind of radio cellular interfaces. And the latest addition we did is Wi-Fi signaling. We added Wi-Fi signaling in all the legacy standards, so to speak, A, B, G, N, and so on, up to AX, and of course also Wi-Fi 7, so 802.11be. 802.11be supports wider bandwidth, higher auto modulation to achieve higher data rates, but it also supports a lot of other features like multi-link operation, for example, multi-resource unit allocations and stuff like that, to have a more efficient use and basically get more data in a better way to the end user. What we are doing here right now is we are testing against a commercial device. It's a Google Pixel 8 inside this little coupling box, shielded box. So there's two antennas, one in the back, one in the bottom. And we connect over these two antennas, then with two RF cables to the RF interface of the CMX500. So with this we can do 2x2 MIMO, and our setup is actually doing 2x2 MIMO 160 MHz in Wi-Fi 7 802.11be. Now if we look at the screen, we have set up a Wi-Fi access point here in our setups. You see this on the left side. The device is already associated, which basically means we have a Wi-Fi access point transmitting a beacon. On the device setting, I can just switch on Wi-Fi. It will see our SSID. I register to my access point, and then we have control, and we can measure the RF interface of this device. And I will do this now, looking here at some transmitter measurements. In this case, you see we allocate only a certain spectrum to that device. So we are using the OFDMA possibilities that Wi-Fi 6 and Wi-Fi 6E and also Wi-Fi 7 supports. So by allocating a certain number of resource blocks to that particular device, and you see this here, for example, in the EVM versus carrier representation, or also in the unused tone error measurement down here. But in that spectrum that the device operates in, we then analyze the modulation accuracy. And you see this big constellation diagram here that basically shows now all the different constellation points on both antennas, because we are running 2x2 MIMO. So you see here antenna 1, antenna 2 representation. You see different colors. I can even switch only to one or the other of these antennas. So now I only have one of these antennas, for example, or one of these signals that I analyze. And you see the results of the different streams here of the error vector magnitude, -40, -43 dBm. And you see the 4K QAM because we are running a highest modulation encoding scheme, MCS13. Of course, we can change that now. Just need to go to the right setting here, and for example, go to another modulation encoding scheme. And you see now this is using 1024 QAM, for example, or we could use another number of tones or another number of resource blocks or resource units that we allocate to the device. And with this, of course, can manipulate now how the uplink signal looks like and can analyze in all these different cases. And the same, of course, for the downlink if you do receiver measurements, packet error rate measurements. So with this, with the integration of Wi-Fi 7 to the cellular radio communication tester CMX500, we are a true multi-technology unit to test also interference, for example, between cellular and non-cellular radios, or also things like, for example, Wi-Fi offloading as we have in another demo on our booth. Thank you very much.